Welcome, my name is Agata Błaszczyk. Now I would like to present the basis of virtual screening. What actually is virtual screening? It is a computer method of analyzing virtual libraries of chemical compounds in search of molecules with potential biological activity. It's an integral part of the drug design process. For many years, technologies based on in vitro screening, called high-throughput screening, have been a key element in the search of new drugs. High-throughput screening allows us to test even tens of thousands of chemical compounds within a day. Nevertheless, the number of identified drug candidates for the optimization process is still low. To improve and speed up the search for new drugs, complementary methods were created. Among them, virtual screening gained the greatest popularity. Remember that the use of virtual screening methods is not intended to replace high-throughput screening. However, computational evaluation is faster and much less expensive than experimental testing. Virtual screening methods can be divided into two categories, based on the protein structure and based on the ligand structure. The structure-based methods are based on the awareness of the target protein structure, which the sought chemical compound is supposed to bind with. In the case of ligand-based methods, when the structure of the compound is known, the virtual library is searched for compounds similar to the active ones. When using this type of methods, it's necessary to know the target protein structure. One of the elements of drug design and discovery process is the optimization of pharmacokinetic properties of the active molecule. The basic principle that describes potential drug characteristics is Lipinski's rule of 5. The structure of the compound should not possess more than 5 hydrogen bond donors and not more than 10 hydrogen bond acceptors. The molecular mass should not exceed 500 Daltons and octanol water partition coefficient should be below 5. Further research had added two more conditions: a polar surface area of maximum 140 angstroms and less than 10 rotatable bonds. Lipinski's rule of 5 is often extended by principle of 3. At the early stage of drug design, it's advisable to apply ADME filtering in addition to pharmacological filtering rules. The table presents the popular commercial software available for predicting ADME. The concept of virtual searching of chemical databases resembles hunting for compounds in the sea of molecules. It is extremely important to choose the chemical space in which we will look for potentially active chemical compounds. The main source of compounds are commercial libraries, where from millions of items you could buy an unlimited number of different molecules. An advantage of this approach is the high availability of compounds and their relatively low cost in comparison with their synthesis. However, screening commercial libraries has also disadvantages. This kind of search reduces the possibility of finding original and yet unexplored compounds. The table lists the most commonly used bases for screening natural products. Marked in blue are the more specific databases, particularly focusing on marine natural products, DMNP, MarineLit and Antibase. For example, Antibase covers marine microbial natural products and includes NMR spectra. In the case of discovering new compounds, it is advisable to use databases suitable for the replication applications. Of the 150,000 known natural products, probability of rediscovery is very high. Therefore, when discovering drugs, efficient replication process is required. If we want the databases to be useful for dereplication purposes, then they should contain specific elements: structure and substructure identity, spectroscopic identity, UV absorption maxima, accurate mass, physical properties, taxonomic identification of the producer, biological activity, and biological targets. Also, the databases should include medicinal chemistry data, natural products data, approved drugs, and unsuccessful drug tests. After database screening, the hit list should be reduced by clustering by chemical similarity and diversity, filtering by various properties, and QSAR prediction. Real thank you from the virtual world!